Okay, we have here another interesting integral from the UNSW CPMS Integration Bee 2023. We have the integral of x cubed plus x over x to the 6th minus 3x to the 4th plus 3x squared minus 1 dx. Okay, so I already did this problem using one method, and I'll provide a link to that other video in the description. But in this video, I'll use a different method. It's going to be a little more straightforward, but I think maybe a little bit longer too, so it's kind of a trade-off. What I want to do in this method is actually factor this, particularly looking at the denominator. Just notice with the coefficients 1, minus 3, 3, minus 1. What I can do is actually rewrite this. This is the same thing as x squared minus 1 cubed. So what I'm going to do is I'm just going to rewrite this with the denominator this way. I'm going to write it as x squared minus 1 cubed. But then what I want to do is try to get some cancellation by manipulating the numerator. So what I can do is I kind of want to force an x squared minus 1 to happen. So what I can do to set this up is I can write my numerator. I'll actually create something like x cubed minus x. The reason I do that is because if you factor that, if I factor an x out of this, it's going to be x times x squared minus 1. That's going to give us this cancellation. But now I don't want to change the numerator, so what if I do, if I just add 2x, now 2x minus x, that gives me the plus x, so now we haven't changed it. So then from here what I can do is actually split this into two integrals. The first one I'm going to split up like this. I'll have this x over x squared minus 1 here. We'll have the same denominator. And for the second one, I'm just going to grab this 2x right here and bring it for the second one. So this is going to become the integral of 2x over x squared minus 1 cubed dx. And like we said, we get cancellation here. So this 3 is going to become a 2. But now this isn't bad because we can do a u substitution on each of these. And I'm actually going to use the same u substitution for both because we've got this x squared minus 1 going on. So for my substitution, I'm going to say, let's just set u equal to x squared minus 1. I'll take a derivative. So our du value is going to be just 2x dx. Well, we're all set over here. We already have 2x dx. So that's our du right there. And then over in this integral, I could just kind of create it by, we'll create it here by multiplying it at 2, but I don't want to change it. So I'll multiply by a half in front. And that way we have a du right here. So let's just go ahead and substitute. So rewriting this first one, we're going to have 1/2 integral of du over u squared. And then for the second one, we're just going to have, this is going to be integral of du over u cubed. And I think I'll just do a quick rewrite because we're going to do power rule on this. So I'm going to write it as u minus 2 du. And then this one I'm going to write as u minus 3 du. So we'll go ahead and integrate. First, we're going to have minus 1/2 1 over u. I'll write it that way. And then integrating the second one, it's going to become minus 1/2 over 1 over u squared. I'll factor a minus 1/2 out of this. And then let's get a common denominator. If I multiply by u over u here to get a u squared in the denominator, this is going to give me u here. I'm going to put it all together with u squared here. But we factor the minus half out here, so this is just going to be a plus 1. Now, just to get a value for u plus 1, just adding a 1 on here, u plus 1 is just going to be x squared. But I'm just going to get some more space to finish this off. Okay, so now I just need to back substitute in order to finish it. So we're going to have our minus 1/2 out front. Our u plus 1 is going to be x squared. U squared, this is going to be x squared minus 1 all squared. But I think just to clean it up, what I'm going to do is we'll write it as minus 1/2 because both things are squared. I'll write it as x over x squared minus 1 all squared plus c, and that's it. Okay, so there you have it. Interesting problem from UNSW CPMS 2023. Thanks everyone for watching. Have a good day.